Hello, I'm Dr. Ian McCullough of Johns Hopkins University. This is a short lecture on social network analysis, graph level measures. There's one learning objective for this lecture: familiarity with basic graph level measures. We have so far studied centrality measures, which describe the influence of a single node within the context of a group. We've studied degree centrality, betweenness centrality, closeness centrality, and to a lesser extent eigenvector centrality. These measures talk about a specific node within the context of the group in which we find them. Graph level measures, however, are describing the group as a whole. We are going to focus on graph level measures that describe group cohesion, activity, and identifying single points of failure in a network. The first measure we are going to discuss is diameter. Diameter is defined as the longest geodesic in the network. A geodesic is a shortest path. So, as we discussed, you could have multiple paths between two nodes in a network. However, the shortest path has the fewest number of steps to get from the source node to the target node. Diameter is a measure of how long it takes information or resources to move from one side of the network to the other. We have two example networks. The one on the left is a star network. It has a single node that dominates the centrality of the network. To the right, we have the ring network. The ring network, every node has the exact same degree and same structural equivalence. No node is more important than another. So if we look at geodesics of length 1, right, 3 to 4 is an example of a path that has a geodesic of length 1. How many geodesics of length 2 are there, or are there any? Well, we see agent 3 to 4 to 5 is a geodesic of length 2. How many geodesics of length 3 exist? You will see none. Therefore, the diameter is 2. Over to the right, we can look and say, is there an example of a geodesic of length 1? Again, 3 to 4 is an example of a geodesic of length 1. Geodesic of length 2, 3, 4, 5 is also in this ring network and is a geodesic of length 2. In the ring network, however, we also have geodesic of length 3, going from 3, 4, 5, 6. There is no geodesic of length 4. If you went all the way around here to agent 1, you would find that there is a shorter path going clockwise around the ring that is shorter. So therefore, there is no geodesic of length 4. Thus, the diameter of this network is length 3. This is how we would calculate diameter. Density is another graph level measure in the network. It is a general level of linkage saying how many connections exist in this group. It is the number of lines in the graph as a proportion of the maximum possible. Here are two examples. If you look at the network to the left, this network describes a communication network among leaders of an Army infantry platoon. So you'll see that there is PL for platoon leader, platoon sergeant, first squad leader, second squad leader, third squad leader. Because there are 5 nodes, there are 5 choose 2 or 10 possible links in the network. In the network to the left, there are only 3 links present. So the density is 3 divided by 10, or 30%, or 0.3. To the right is the similar network, only in this case there is much more connectivity. There are 8 links present out of the 10 possible, so the density is 80%, or 0.8. There are a couple interesting things about density. First of all, density is equivalent to the average degree of the node. It is looking at how many links are present out of all possible. If you do some math and some meditation on that, you will see that there is an equivalence between the average degree and the density of the network. Whether we have a high density or a low density really depends upon the size of the network. Small networks have a higher density typically. A lot of this has to do with cognitive limitations people have on the number of links that they can have or maintain. If you're in a group of 10 people, it's quite likely that you know everybody in the group, as does everybody else in the group. So to have a density of 1 in a 10-person group is not uncommon. When the network gets to 1,000, the likelihood of knowing 1,000 people in the organization is much smaller, and the density will not likely be 1. Therefore, density is a measure that does not scale well with different sizes, and whether you have a high or low density really depends upon the size of the network. This has been a short lecture on graph level measures. I am Dr. Ian McCullough of Johns Hopkins University.